A lot of what we're doing you have already done last year, but it's always helpful to go through it all again and re-familiarize yourself, especially with some of the notation that we're going to be going through again. But today, this stuff is back to the very basics, review of probability. So probability, which is sometimes called chance, is when you calculate the likelihood of an event occurring. Probabilities lie between a 0 and a 1. Usually we write them as fractions. You could write them as decimals, however. Or if you write it as a percentage, it would be between 0 and 100%. So below we have a diagram that describes approximately the places on the probability scale. Using a word scale is not very precise, so we don't use it very often, as people still don't know exactly what you mean. But some of the words that you should be familiar with, if you have a 0 probability, it means that it is impossible for that event to occur. If something has a probability of 1 or 100%, it is certainly going to occur. And then the other main one that we have is our even chance, which is our 0.5 or 50% in the middle. Anything between 0 and 0.5 is unlikely. And you have all these different scales of unlikely. You have highly unlikely, very unlikely, unlikely, and a less than even chance. But all of those things are less than 0.5. It is unlikely for that event to occur. But you can see how that would be very hard to describe something using one of those 4 different categories there. Anything between 0.5 and 1 means that it is likely to occur. It's better than half a chance that that event will occur, and you have those scales in there as well. But the 3 that I've highlighted are your main ones, and the ones in between we don't use as much. Some other terms that you need to know in this topic, there's quite a few of them, so let's go through them all together. So terms that you must understand. First of all, a trial is the number of times that you conduct an experiment. So if you roll a dice 10 times, then that means there is 10 trials. There was 10 things that you did. The outcome is the result that you get from each trial. So if you roll that dice 10 times like we did before, then the different outcomes that you can get are 1, 2, 3, 4, 5, and 6. They are the possible outcomes that you could get. Event. You're going to hear that word a lot. If I say, what is the probability of this event? It is the probability of that desired or favorable outcome happening. So you want to know how many times it is possible for that event to occur. Equally likely outcomes means that they have an equal chance of occurring. So you think of flipping a coin, unless it's a biased coin, but usually a coin, you think a head and a tail, they are equally likely to occur. An impossible event we've already covered, but there it is again. It means that it has a probability of 0. Even a very, very small chance, though, does not mean that something is impossible. If there's any skerrick of a chance, then it is not impossible, okay? A definite event means that that will definitely happen 100%, without a doubt, no way of avoiding it. That event must happen. So on a normal dice, the numbers 1 to 6, the probability of rolling a number less than 7 is certain, because that's all that you can roll, okay? The sample space, we use the letter S to represent sample space. It is a list of all the possible outcomes for your experiment. We put them in these curly brackets, like I'm highlighting here, and you'll see it written like this. So if I was writing the sample space for rolling a dice again, you've got S for sample space equals big curly brackets, and then you list off the possible outcomes, 1, 2, 3, 4, 5, 6, close your curly brackets, and that's the proper way to list off a sample space. The complement. The probabilities of any event should always add up to equal 1. So if you know the probability of rolling a 6 on a coin is a 1 in 6 chance, the complement means everything else, everything other than that outcome that I've described. And so the easiest way to calculate that for some questions is just to do 1 minus the part that you already know, and that will tell you the part that you want. Does that make sense? So if the probability of rolling a 6 is 1 out of 6, then the probability of not rolling a 6 is 1 minus 1 over 6, which is 5 over 6. Very wordy, okay? But you know what I mean? This formula here, you have seen since the beginning of high school, or maybe even earlier. The probability of an event is equal to the number of favorable outcomes over the number of trials, or the number of possible outcomes. So you'll be using that formula as well. So let's get into it. Examples. A letter is chosen at random from the statement, mathematics is fun. Find the following probabilities. So there's some notation in here. You see the P bracket M. The P stands for probability. I want to find the probability. And the thing in the bracket is what you want to find the probability of. I want to find that reads as the probability of getting an M. So I look at my statement written in capital letters there, and I want to find all the M's. There's one there, and there's one there. That's it. There's 2 M's in that statement. So using that formula that we just went through, the number of favorable outcomes is 2 because there's 2 M's. How many outcomes are there altogether? You need to sit there and count up all those letters. Has anyone done it? 16, perfect. Now, as I said before, we usually like to leave our answers as fractions, but they should be simplified. And this fraction can be simplified. Dividing top and bottom by 2, I get 1 over 8. Part B, find the probability that we do not get an M. So you could sit there and count up all the letters that are not M, but for practice, let's use that complementary rule that we talked about in those terms before. If I were to find since I found the probability of M, not M is just going to be 1 minus the probability of getting an M, which was 1 over 8. 1 minus 1 over 8 is 7 over 8. Okay, so that's using the complementary rule. Part C says, find the probability of getting a vowel. So your vowels are A, E, I, O, and U. So we look through our statement again and highlight or put a mark next to all the vowels. So there's 1, 2, 3, 4, 5, 6. Yes.
How did you get 7 from 1 minus?
So 1 is the same as 8 over 8.
Yeah.
And then 8 minus 1 makes 7 over 8. Or you can just type the whole thing in your calculator. Okay? All right, so counting up those vowels, I have got 6 vowels out of the 16 letters. So number of favorable outcomes over the total number of outcomes. Can I simplify that fraction?
Yeah.
Yes.
3 over 8.
That's right. Divide top and bottom by 2 again to get 3 over 8. So here's some extra practice for you, Ruby. Now I want to do the probability of not getting a vowel. So using the complementary rule, I could go 1 minus the probability of a vowel, which is 3 over 8. Can you subtract that in your head? All you need to do is, if you've got 3 over 8, you just want to count up how many more 8s are there. So 3, 4, 5, 6, 7, 8. There's 5 to make it to a whole. So that would be 5 8s. Maya? Question 1E. Find the probability of a vowel or an M. So it can be either of them. I've already got my vowels highlighted, but it means that I can get the M's as well. And remember there was 2 M's in there. So how many letters is that altogether? 8, correct. 8 favourable outcomes out of 16. Can it be simplified? Yep. Divide by 8 and we get 1 over 2. Part F. What is the probability of getting a vowel or a consonant? So we know the vowels are A, E, I, O, U. Consonants are everything else. They're all the letters that are not vowels. So how many letters in Mathematics is Fun are vowels or consonants? All of them. So all of them are either vowels or consonants. So that's 16 out of 16. In other words, that's a probability of 1. So if you choose a letter out of there, you're always going to get either a vowel or a consonant because that's all that's in there. Okay, so hopefully you are familiar with using that formula. The next type of question, question number 2, is to do with packs of cards. Now, unfortunately, you do need to be familiar with a pack of cards. There is often questions involving them, so you are expected to know what is in a pack of cards. So there is, we don't count jokers, for those of you, or there's always someone who likes to say, what about the jokers? You don't count jokers, we just want the standard 52 cards, the normal playing cards in a deck. There are 4 suits. The 4 suits are clubs, hearts, spades, and diamonds. 2 of the suits are what we call red, so you can see that they're red, and 2 of the suits are what we call black. There is 13 cards in each suit. The ace is normally considered a 1, something depending on the game. And then from 1 up to 10, so ace up to 10, and then you have your jack, queen, and king, so 13 cards. All right, so the picture will not always be there for you in card questions though, but for this one it is, for those of you who need a bit of a visual. So doing some probability questions. Question 2A says, find the probability that the card will be the 5 of spades. So looking through my picture there, the 5 of spades, the spades is the 3rd row down, and it's that one there that I've highlighted in pink. There is only one card that is what we call the 5 of spades. So that means it's a probability of 1 out of 52 because there's 52 cards in our deck. Part B is the probability of getting a jack. Jacks are the ones that have the J on them, and there's 1 in each suit, these 4 down here that I'm highlighting in pink. So that means 4 altogether out of the 52, which we would have to simplify down, which is 1 out of 13, because it makes sense. In each row of 13, there's 1 out of 13. Part C, find the probability of getting a black card. So you can count them all up, all of the clubs and all of the spades, they're the black cards, and there's 26 of them. However, that is exactly half, which makes sense because half the cards are black and half the cards are red. A diamond.
Which is a quarter.
Yep, so your diamonds are down here. You could go straight to a quarter, that's fine. Or there is 13 because one whole row of that is going to be 13 out of 52, which is a quarter. An even number. So even numbers are 2, 4, 6, 8, and 10. So that's 1, 2, 3, 4, 5 rows that I've highlighted there. 5 times 4 means 20 cards. 20 out of 52, which does equal, what? 5 out of what? 13. Shh, Charlie, stop talking or you're not going to be sitting together. F, any card except a 7. So the only ones that we don't want are the 7. So you can count up everything else, or you could just go 52 minus the 4 that I don't want, which is 48 out of 52. Use your calculator, simplify it down, and you get 12 out of 13. Maya. Oh, I thought she said yes. No. G, not a red queen. So I don't want the red queen, so I'm going to cross them out. Cross out that queen, cross out that queen, but I want everything else. So there's only 2 cards that I don't want, which means that there's 50 that I do want out of 52. Simplify.
25 and 26?
Yes.
How do you simplify?
You just type them in your calculator and press equals. Or you just go, what can I divide both of those by? And so you can divide both of those by 2, which is how you get that. Okay, last one, a red card or a club. So I want the clubs and I want all the red ones, which means I want those 3 rows. So 3 lots of 13 is 39 out of the 52, which obviously simplifies to 3/4. So I want 3 out of the 4 rows. Okay, so questions involving cards. Next page, question 3. That shouldn't happen because they should always be less than 1, so you shouldn't get any mixed numerals. So question 3, we're doing an experiment that involves rolling a dice 100 times, and the results are as follows. So when you roll a dice, you know that you can get the numbers 1, 2, 3, 4, 5, and 6. So that's the top numbers there on the top row of that table. They're your possible outcomes. The results that are underneath there are how many times you get each of those numbers. If you add them all up, what should you get? You shouldn't need to do it. 100. Okay, so we've rolled the dice 100 times, and out of 100 times, I got a 1 20 times. The 2 I got 14 times, the 3 I got 18 times, the 4 I got 23 times, 5 I got 19 times, and 6 I got 6 times. Now this is what we call experimental probability, because we actually sat there and rolled the dice, and they came out not perfectly even. Theoretical probability tells me that it should have an even chance of getting each one, and all of those results should have come out perfectly. And if you kept rolling that dice 1,000 times or 10,000 times, the experimental probability should get closer and closer to the theoretical probability. But we all know that when you play a game that has a dice, there are times when you might just get an awful lot of 6s or an awful lot of whatever one number, and it doesn't always work out perfectly the way theoretical probability tells us it should. Okay, so these questions are using the table. It says you find the experimental probability, not the theoretical one, the experimental one from the table. And we want the probability of rolling a 6. So that's these ones on the ends here. There's my 6, and I rolled a 6 6 times. So that was 6 times out of the 100 times that I did the experiment. Simplify the fraction down so I can divide top and bottom by 2, gives me 3 out of 50. Not our usual 1 out of 6 that we would expect. All right, next one. Find the probability of getting an odd number. So the odd numbers are 1, 3, and 5. So you would need to add together the 20, the 18, and the 19. Now, I wouldn't expect you to write this down in a test, but you may want to write it for your notes just so you remember how you got the answer. You add together those numbers and you put it over 100. When you add them together, you get 57 out of 100. Part C. What is the probability of getting less than 4? Now, be careful with the wording in probability questions because that's one of the ways that we try to trick you. Okay? So less than 4, does that include 4? No. So it only is the numbers 1, 2, and 3. So it's those 3 there, the 20, the 14, and the 18. So again, I could add those up. 20 plus 14 plus 18 over 100. And that equals 52 over 100. That one simplifies down. I can divide by 4 to get 13 out of 25.
But the next one's harder.
Okay, the wording again. It says at least 3. Does that include the 3? Yes. So it means I can have 3 or higher. At least 3 means I want 3 or bigger. So I add together the 18, the 23, the 19, and the 6, and I put that over 100. That makes 66 out of 100, which simplifies to 33 out of 50. Okay, any questions there? All right, great. So that means that you can do the questions down the bottom here from exercise 3A.